Right, so we'll get started. Like I said, the agenda for today is the lecturing part or the discussion part is quite short. Because as you know, we have two remaining case studies to work on, which is both are open-ended. So they're both on Moodle. I posted a PDF of the instruction of some kind of possible research questions you can explore together with the data set. And of course, places that you can post later once you work on it. So I want to spend the time today in class to talk about both of them a little bit and look at certain things that you might want to explore. And of course, we have covered multiple modeling techniques in class, for example, hierarchical modeling, simple linear regression, multiple linear regression. So those are the things that the tools that you could use when you're working both case studies. So let me talk about the first one first. It's called the marriage rate in Italy. The data, let me try to zoom this in. Yeah. So data actually contains annual marriage counts per 1,000 person in the population in Italy from 1936 to 1961. Okay. So data, if you go to Moodle, let me open this different way. If you go to Moodle, it's going to be here. It's a CSV file that you can download and work with. So that's actually a very simple data set. And there's some questions that I posted over here. So with that, let me show you the plot of a simple plot of the data. And maybe you can work on that. Let me just sign in. Show you. Like I said, a simple plot in a way that might give you a sense of what kind of how this kind of questions, we list a few over here that could be explained using certain modeling technique. Okay, so let me get you the plot. So this is the plot itself. Once you do, once you download the R file, you will see that there are simply two columns. Okay, one of them is the year, and the other one is the rate, the marriage rate. Like I said, for people doing this particular time. So if you plot it out, the marriage rate, which is the variable that we're interested in, by year, you can see a trend like this. Okay. I put the two lines over here, mostly just to give you a sense that, well, if you look at the question here, are marriage rates before, during, and after World War II the same or different? Okay, so I was picking the two time points between, I guess, before, during, and after. So we can have the three different timelines over here. And then you can see that whether, or you can guess, or you can infer using certain methodology, whether there are indeed differences going on between the three different periods of time. Okay? So that's a simple plot. Like I said, the data set is pretty straightforward. Once you get the CSV file, it's only two columns. Okay, one is the year itself, and then the other one is the rate. That is the outcome variable of interest. So I'll just read off those questions. So like I said, marriage rates before, during, and after World War II the same or not, and what are possible Bayesian methods that you would like to use to approach this problem. When you're doing that, what kind of assumptions you're making, and can you justify the assumptions that you're making before you fit the model? And then, of course, make sure that you recognize what are the parameters in your model. And once you recognize what they are, the natural step, as we know in Bayesian inference, is trying to pick the appropriate prior distributions for them. And you could also discuss whether full conditional distributions are recognizable or not, depending on whether you want to do some derivation or not. But like I said, mostly for this kind of applications, we rely on JAX to do the MCMC inference for us. So not necessarily you need to derive the model or showing whether the posterior distributions or the full conditional posterior distributions are recognizable or not. So you should also discuss what is your computation method, for example, using JAX. And then, of course, if you're using JAX, make sure that you write the model string and also how to pass the data and all of the MCMC. The posterior summary, very similar to what we used to do. You need to figure out which are the parameters of your interest. So if you're using JAX, you're going to put them into the monitor command, right? And then making sure that you check those parameters and all that. And then, of course, make sure you check MC diagnostics for all of the parameters in the model to make sure that there's no divergence issues in your estimation. And then finally, what will be your conclusion regarding the marriage rates across the 3 different periods of time. So this is the first case study, open-ended. Like I said, there is some guiding question over there, but then much of this is really talking about the Bayesian methods and then how you set up your model, how you can do your MC estimation, and from there, how can you make conclusion based on your posterior summary. Okay, yeah, so this is a simpler data set, like I said. Sorry about that, but you're here now, so that's good. Okay, and oh yeah, I should fix it, I guess, in that case. Missing a 2 at the end. Sorry. That's some try and error. You got it. Congratulations. All right. Okay. So that's the first case study. Okay. And the second case study. Is about students or test takers true or false exam scores. Okay, so we got 15 people sitting in exam, which is made up of 40 true or false questions. So you're going to see whether they get it right or not, and each going to receive a score afterwards. Data set is stored in this true false scores.csv file. Okay. So I want to talk to you a little bit about the data. So let me show you a simple plot. And then I can talk about some possible approaches, and then we'll let you to work on your own stuff. All right, so there are 15 students, okay, or test takers. On the y-axis, we have the score, which is up to 40, because that's the total number of questions. And then you get a point for a correct answer, you get a 0 for an incorrect answer for each question. And we got 15 observations. So we're plotting the index on the x-axis as just the index of the test taker. Okay. So at a first glance of this data, you might see a little cluster at the bottom here. Okay. Those are people seemingly around 20. So that's kind of like a random guessing group. If you imagine they don't really have the knowledge, for example, and it's purely guessing the answer because it's true or false. And then we seem to have another cluster up here that are having, seem to have some knowledge around 35, which is pretty high according to like a 40 as the full score. Okay, so this is what the data is telling us. Okay, so some questions for you to explore. Okay, like I said, some analysis might claim that this scores, the graph that we saw, suggest a what we call random guessing group, the first 5 that are clustered lower around 20, and then the last 10 has some level of knowledge. Okay, so this is a proposal or proposed possibility here. If you want to explore that, what will be your Bayesian methods, assumptions, and are they justified? Here, I'm proposing something that you might want to take into consideration when you're doing this case study is, of course, we're assuming people are coming from 2 groups. One group is the guessing group. The other one we can call it as a knowledge group or knowledgeable group. And this group's going to have different probabilities of scoring correctly. Okay, so if you have 2 groups going on over here, okay, so we could imagine that one group is the random guessing group, the other one is knowledge group, and then within them, observations are kind of independent from each other, okay, and similar to each other. And then another idea you can consider is whether people have individual specific success probability. Okay, so although right now, if we think about 2 groups, then you might have a group specific success probability for all of the observations within the same group. Okay, but you could also, if you want, have an individual specific success probability. So if you're setting up, say, PI as the successful observation I, you can have PIJ, where J is a group indicator, right? Based on how we have learned hierarchical model in the past, okay? And you could also have this PIJ, very specific to each observation, if you want to set up a hierarchical model that way. And then if you do that, then of course, make sure that you know what the parameters are in the model, what are the prior distribution, whether, or I should say, what kind of computing scheme you're gonna have. And here I propose and you included some useful JAX function in case you want to do any kind of truncation and et cetera, okay? And lastly, what is your posterior summary of the parameters, as well as MCMC diagnostics? And then lastly, going back to the initial question of, do you think there really exist two groups, okay? The random guessing group, as well as the knowledgeable group based on the outcome that we have seen over here. So another thing that I included over here is another extension that you might want to do is, well, instead of knowing which observation belongs to each group, we might also think that could be unknown, and that could be a random thing that might be going on. So even though I see two groups over here, like the lower group and the upper group, but for observations like this one, well, maybe very likely it belongs to the random guessing group, but maybe the person could be at the knowledgeable group as well. Or observation like this too, that they're relatively low, they are still higher than the lower group, but they're on the lower end of the higher group. So whether these two observations should really belong to the lower group, or I should say the higher group, or maybe there's certain possibility that they actually belong to the lower group. So that's another strategy that you could consider if you want to set up a model like that. And if that is the case, then this equals JAX function might be useful when you're trying to indicate whether an observation comes from the first group or the second group. Okay, so both are open-ended, and the plan is, if you look at our schedule, schedule here, yeah. So today in class, this is all I actually want to discuss, and then you will get the chance to either work on this if you want, or you can work on your project, because we have this methodology drafted early next week. So we're gonna do Q&A and all that over there. And then on Wednesday next week, we're gonna spend most of, I don't know how long, but we're gonna spend the lecturing part on how to work out case study number 1. Okay, so for case study number 1, we will have you team up really, okay, just like lab 5. And then you will make a post, I think, let's just say by Wednesday noon before we meet for class. So we'll have the participation grade for that. And then in class, we're gonna discuss the results from each of the team that you team up yourself. And then on Friday next week, we're gonna discuss case study number 2. So just like case study number 1, you're allowed to freely team up by yourselves, or if you want to work on it individually, that's fine as well. And now on Moodle, we have this place that you can post your analysis in the forum format, just like what you used to do. And so people will get a notification whenever people post it. So that will be the plan for the Wednesday on the 27th. Next Friday, we actually have a Bayesian statistician who works at Skidmore College, so 2 hours north from here. So we got this guest lecture coming to our class first to give an intro to variational inference. So that's not MCMC for Bayesian estimation, but sometimes the models can get really complicated that regular MCMC wouldn't work. This researcher, he works on what we call variational inference as an alternative to MCMC for Bayesian inference. So he's going to give a guest lecture. And the Friday, that same Friday, after our class, 3:30 to 4:30, he will also give a Department of Colloquium in Rocky. So I'll also send out the information. If you can stop by, that will be good. So that's the plan for, like I said, Wednesday next week is case study 1 discussion. Friday is going to be a guest lecture. And then the Wednesday after, which is the second last class, we're going to have it for case study number 2 discussion. And then finally, the last class of our course, which is 2 weeks away, will be a poster session. We're going to reserve a room back in Rocky, so you can post, print out your project, a slides format, and then you're just going to tape it on the wall, and then we're going to do a academic style poster session. People can come to your session, can come to a poster, and then you can discuss instead of giving a presentation in front of the class. Okay. So I think given the number of projects that we have in the course, we'll have like within this 75 minutes, we're gonna have 2 sessions. So the first group, there will be half of the teams gonna be presenting and then the other half walking around and asking questions. And then after that, the second group will just do the reverse. Okay, so that's the plan for Friday. But like I said, just to make sure that everybody's making steady progress on the project, early next week, we have the methodology draft due. And then also the week after, we're gonna have the final project draft as well. For both of this, I won't grade anything, but I will provide detailed feedback as what you can improve. And so that's the rest of the semester pretty much, okay? And lab 5, also I think, so for lab 5, case study 1 and case study 2, you can freely team up, like I said. So if you click this link at the top, you can sign up over here. So I see that for lab 5, some of you already signed up as how you want to work in teams. And then, so I will just use this this tab when I'm grading the lab 5 and all that. Okay, and similarly for case study number 1 and number 2, yeah, I see people signing up, that's good. So you can sign up accordingly as well. Okay, so this just be a way for me to keep grading and the assignment of the grades correct. And also, so for lab 5, lab 1 through 5, you get a lab grade and all that. For case study 1 and 2, they're just participation grades as long as you have participated. Okay, so nothing is gonna be graded based on correctness or not. Like I said, both case studies are pretty open-ended, so I don't think there is a fixed answer out there, but we'd like to see how every team is approaching the question might be differently. Yes, Abigail?
Did you want us posting an answer for all of the questions for the case studies, or are we doing one question?
Yeah, so I would say, for example, like the main question is this one, pretty much, the first one, but then everything else, whatever you posted. So for example, if you use a markdown file, you will probably include your JAX code, how you fit the model, what is your posterior summary and all that. So I think even though we have this few questions over here, you don't need to answer each one specifically, but I think by including the entire analysis process, we probably answer most of them already. Yeah. Okay. Anything else? Yeah, Carl?
What's the expectations for the methodology?
Yeah, sure. Right. So if you want to take a look, I think at the very beginning of our lecture, I show you, which is beginning of the semester, I show you some previous projects from previous classes. Yeah, so for the methodology, so if you look at our instructions of the project, let me just open this here. Yeah. Yeah, so you can use up to 20 slides, whichever you want to use, PowerPoints or other like LaTeX or Beamer. If you want to use that, that's totally fine. So for us, the methodology draft is usually this part, which is the methods that you use to obtain and I guess mostly analyze the data. So depends on what kind of methods you use. For example, if you're using an existing Bayesian method that we covered in class, then I think you don't need too many slides to describe what it is, because I assume each audience already knows enough, because the audience is our whole class. So if you're using linear regression or something like that, or hierarchical modeling, maybe just a couple of slides of the general strategy, that will be sufficient, okay? But then for the rest of projects like that, then you will, I think, devote time to discuss all of the other aspects, especially the results of the analysis and all that. So I think for projects utilizing an existing method that we covered in class, you don't need to have a very long methodology draft itself, okay? But I know many of us are actually exploring new methodologies. So when that happens, I would say spend, I don't know, maybe 8 to 10-ish slides to talk about the method itself, because you could imagine that someone else in our class walked to your poster, most likely they won't know much about, well, what you're presenting in terms of the method. So I think that will be the difference between how you approach this methodology draft. Yeah, so I think for those of you who are doing a project that is more applied focus with existing methodology, then of course by next Monday, when you submit your methodology draft, you should have the methodology part ready. But for those of you, like I said, who are doing an applied project, you might already make some progress on the other aspects of the project. I'm happy to give feedback as well. Yeah, so for this part, really, I'm just trying to put 2 checkpoints, right? One is for the methodology draft, the other one is for the final draft, to make sure that every team is making progress steadily. But in terms of the focus, like how many pages you need for one aspect and the other, I think it could be a particular balance given the project that you're doing, yeah. Yeah, but like I said, I'm not grading any of this for the grade, but mostly trying to make sure that everybody is making progress, as well as if I see anything is lacking, I can provide feedback, just like what I do for the proposal as well. Yes, Sarah?
Wait, is there a paper attached to this or is this just a project?
Just the, yeah,
Okay.
so no write-up for the project itself. So the final product will be a poster session, which is up to
Okay.
20 pages of slides or
Yeah.
20 slides. Yeah, so that everything goes in here. Yeah. And if you look at this instructions document, I think we also share certain aspects of how you can present your analysis most effectively and all that. So, but of course, specific questions, I'm happy to answer as soon as you have them. Okay. Anything else? I mean, if anything, of course, just speak up. I'm gonna stop share and stop recording for the moment. But if anything is important for everybody to know, I will resume the recording again. And for the rest of the class, you can, like I said, work on lab 5, which is due next Friday, okay? Or your projects, which has this methodology draft due early next week. And case study number 1, which is the marriage rates exercise, we're gonna talk about it on Wednesday next week. So I will just ask every team who will team up eventually for participation grade to write a report, whatever format. If you write it in the markdown, just knit it as a PDF, including all of the steps that you need to include, and then post it on Moodle. That will count towards the participation grade for everybody on that team. All right, let me start recording, and I will just walk around answering any questions you might have. And Nat, you can of course speak up whenever. And thank you for trying that last digit. That's very nice.